Welcome back to the lecture series of Halliday Resnick Krane Volume 2. In this lecture, I will discuss about the MCQ solution of chapter 31, that is DC circuit, and I will discuss from question 1 to question number 7. So, let's begin. Question number 1. The junction rule is a direct consequence of Newton's second law, conservation of momentum, conservation of energy, or conservation of charge. First of all, we should know that what is junction means point where different paths are basically meet out. Junction rule is also named as Kirchhoff's first rule that states at any junction the total current that is entering through the junction must be equal to the current that is leaving through junction. Here in this diagram you can see that I1, I2, I5 and I4 are basically entering to the junction. Sum of these current is basically equal to the current that are leaving out of the junction, for example I3 and I6. So you know that the current is basically flow of charges. The sum of the current that is entering the junction is equal to the sum of the current that is leaving out of the junction. It means that there is a conservation of charge. No extra charge is either creating or destroying here. So this junction rule is basically conservation of charge. Question number 2. The figure shows a network of wires carrying various current. What is the current through A? So we have to tell what is the current through this point. So option A is 1 ampere, option B is 2 ampere, 3 ampere, 9 ampere or 11 ampere. If there is the 10 ampere current that is entering to this point, 7 is here and 3 is here. After that, from 7 ampere 4 is going down there. So it means that you are left with 3 ampere here. You can also verify it. When this 3 ampere is basically meeting at this point with this 3 ampere, you get 6 ampere. And now this is again 10 ampere that is going out of the junction. So basically option C is the correct option. Question number 3. We also have a figure that shows a network of wires carrying various currents. What is the current that is passing through this point A? So options are 1 ampere, 2 ampere, 6 ampere, 8 amperes, or there is not enough information that is given in the question. So consider the junction rule. If 11 ampere is basically entering to this point, 3 ampere is there. So it means that you have 8 ampere currents here. If 8 ampere current is there and 5 ampere is going upward, then it means that you have left with 3 ampere here. As well as if there is 3 ampere, then you have 8 ampere because 5 ampere is adding at this point with 3 ampere and you are getting 8 amperes. Next, if 8 ampere is coming through this junction, then you have 2 ampere here and 6 ampere here, for example. Because you have 5 ampere here, so it means that 3 and from this junction you will get 2 ampere, 3 plus 2 you get 5 ampere that is going through this junction, and after the 6, 5 you will get the 11 ampere that was in the starting of the network. So option B is the correct option. Question number 4. What are the units for EMF, the electromotive force? As the word indicates that it might be a force, but actually electromotive force is defined as the work done per unit charge, and the unit of work done is joule and charge is coulomb. So joule per coulomb is volt. So option C is the correct option. The unit for electromotive force is not Newton, it's a volt. Question number 5. The function of source of EMF in a circuit is to supply electrons to the circuit, raise electron to a higher potential, push electrons to a lower potential, or accelerate electrons to greater speed. So basically electromotive force is raising the electrons to higher potential, and then after that they just continue their cycle by firing towards the lower potential and so on. So option B is the correct option. Question number 6. The loop rule is a direct consequence of Newton's second law, conservation of momentum, conservation of energy, or conservation of charge. The loop rule is also named as Kirchhoff's second rule, which states that the algebraic sum of all differences in potential around a complete circuit loop must be 0. In this loop rule, if the battery is providing certain potential, then the potential drop across each resistor or appliances is basically conserved. So the loop rule is basically a direct consequence of conservation of energy. So option C is the correct option. Question number 7. A fixed resistor is in series with the